the idea of doing this is people did notice this anomaly, and physics people noticed this anomaly, and then mathematicians began to ask, okay, how do we understand this structure in terms of something topological, because this is topological invariant, and so they came up with the idea, well, there must be some, in fact, they were thinking about earlier, there's got to be some notion of the number of eigenvalues of differing chiralities, or eigenvectors of differing chiralities that have zero eigenvalues. It's possible to show when the eigenvalue is non-zero, the things all have to be paired. And the only way to get a lack of pairing is at the zero eigenvalue level. So let me go on a little bit to just get Delphi's ideas. So suppose we're given, or we have some one form on a manifold M, then in general, if I have some manifold, I'll need several patches, right, on which I define the manifold. For example, a sphere, I could have the northern hemisphere and the southern hemisphere, or a torus. I could define various pieces of it. So we have these overlap regions here. And in an overlap region, with U1, U2, and these U's are the various patches, etc. 3, I don't know how many U's there are. So A of Ui would be related to some coordinate transformation between the I and the J patch, like so, where they overlap. So a gauge field, I'll have a well-defined theory if on patch J, if the gauge field on patch I is related to the gauge field on patch J via a gauge transformation that is defined on the overlap. So these are, this is and group elements are defined here. They might be defined elsewhere, but I at least need them to be defined in the patches. These are transition functions. Different patches of manifold. So a characteristic class is a closed form on a manifold constructed from a gauge field string. So you give me, if I have some gauge field, I can construct a field strength, and if you can give me an object that is closed, then that thing is called a characteristic class. And the integral of that class is sensitive to the transition functions, in the sense that I can always solve, let's see, closed form, let's call it P. So I have dt equals 0. So locally, by Poincaré's lemma, I could write P as d of d as d of q, say, where the Q's, of course, will be sensitive to the transition functions. They'll be defined patch by patch. And if I can do this everywhere, then I've got a trivial solution. But if I cannot write this the same way everywhere, in other words, if there's a non-trivial relation between the Q's from patch to patch, then I have an interesting gauge topological structure of the energy. So, the one example we saw already is that T could be the trace of f to the n. dt is in a 2n dimensional manifold, this is the 2 form, so it'll saturate it. So it has to, because it has as many dx's as there are dimensions, d of this thing has to be 0. And it is certainly a closed form, but because of the anomaly, it's not necessarily an exact form. It's not necessarily the d of something. So if omega is d omega plus omega squared, then we must have P of G inverse omega G to be P of omega. It's got to be gauge invariant, and P is some polynomial. Or rather, could always be expanded as a polynomial in the gauge potential. If you constructed some other function, because it's a form, I could expand that function for small values of the argument, and eventually the number of dx's will be larger than the manifold, and the power series will truncate, and so you're going to get a polynomial. Yeah. Well, the consequence will be that you will have, it'll be a measure of the topological non-triviality of your manifold. Yeah, that's right. So, in fact, the integral of P will give a number, and that number is a thumbprint that tells you something about your manifold that you would not learn locally. So locally, you can always do this. And the integral...
We are poised to play a bigger role in this world.
この番組はさまざまな世代のサウンドクリエイターが月替わりで登場します。作品にまつわる秘話や影響を受けた
Ethiopia, the second leg of his African trip. Dozens of Afghan police, including their commanders, have deserted, joined the Taliban in eastern Afghanistan. Officials say the base had been cut off by flash